Maybe not to get onto the wireless. The US cell phone type to register. Both of these things, because you need the entire phone number. Not to receive the message. That would be.
I have an Italian number. I do. Yeah, let's see. Okay. Test. Where's that audio coming from? Stop screen sharing. It said Dante.
Test 1, 2, test.
Audio check, test one. This is an audio test. Check one,
Yeah.
2, 3.
It's working.
And then if I want to just hide it.
Check 1, 2. Ricky, I'm connecting from downstairs.
And Marco, did you want to do a test?
Sure. Can you hear me?
Yes.
All right.
Your audio sounds good. And we can see you just fine.
Start my camera and I can share my screen really quick. Okay.
That looks great.
Looking
It's Wi-Fi.
okay. Should be good for remote speakers.
Your audio was breaking up just a little bit, but I think we're okay.
Hello. Good morning, everyone. I think we are already 10 minutes behind, but we are still waiting for a few people downstairs who are picking up their badges. So let's wait for a few more minutes. I'm sure you would appreciate putting together such a meeting like this after a break of 4 years is not without challenges. So but glad to see so many of you in the audience, and just give us a few more minutes. So also attendees online, if you can hear me, just stay around. You will not lose your minutes. We will adjust everything somehow. Be back in a minute. Hello. Hi, everyone. Let's get things started. I think we are almost there, slightly behind schedule, but we'll try to make up as we go during the day. So first of all, very warm welcome and I do mean warm. Those of you actually had the joy of walking at 7 o'clock this morning already felt what it would be like later in the day. So let's make this meeting also very warm and have a lot of interactions. Let me introduce myself. So my name is Mahesh Anand, and I'm one of the co-chairs of the ELS committee. And I'm joined by my co-chair, Professor Matteo Massoroni, who is also hosting this meeting at this university. So huge thank to Matteo and his team, but I'm sure we will have time to thank them properly at the end of the meeting. There will be few announcements, so I think we are still 5 minutes away from actually starting the session, but it's really important that you know, in case of emergency, what to do if a fire alarm goes off. That's really, really important. So there are 4 exit doors, 2 at the bottom and 2 above, and you just follow the path that you came in and you go outside the building. Hopefully nothing like that will happen. And the second thing is it's all about water. Life depends on water. And I know though many of you actually have noticed that we haven't yet got the water point sorted out. So it will be arriving later today, along with the second thing that all of us need, which is called coffee or tea. Will also be arriving, but because it's so warm, probably you're not missing coffee or tea that much as it would keep you awake. But anyway, we'll try to keep you awake. So after the water and tea and coffee and the emergency procedures, there are a few other logistics that Matteo will cover. All I'm here to say is really how grateful I am to Matteo, University of Padua, and to you to come here. I mean, it has been 4 years in the making. I mean, I recognize so many faces in this room, probably 3/4. And we were all together in 2019, if you remember, in Manchester for the last European Lunar Symposium, and we were going to meet here in 2020. And this was probably the first international meeting that was canceled in Europe as a result of the pandemic, and we didn't know how we would emerge. And I'm really glad to say and see that I think we have put that episode behind us. So we're all together again, and it was so wonderful to see that the majority of the people who chose to submit an abstract and register for this meeting wanted to come in person. That makes a statement, and by far this is going to be the biggest lunar symposium that we have held. This is the 11th version, 8th one in person, because we had 3 in between in virtual mode. And we are going to have over 250 people in person, which is a record. And we received close to 200 abstracts. The only downside to that was that last year when I actually sent out the feelers in the community, if you would attend in person, only 70 responses were received. So we booked this place for 3 days. And we received 175 abstracts, just the abstract. So that made our life a little bit trickier. And I know some of you are not very happy that we have a couple of parallel sessions, but we had no other choice for this meeting. But believe me, going forward, we will be planning for just plenaries and longer talk times. I know this time we also had to keep talks to only 10 minutes. So please, 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 we are not doing favors to anybody, as you would have seen, even the VIPs among us, they still have only 10 minutes allocated to their presentation. So what we are going to do is, as whoever is chairing here would keep the time, and towards the end of 8 minutes, there will be a warning, right, that you've got 2 minutes left. And in that 2 minutes, you either actually finish your talk, or you might have to start walking that way so that the next speaker can actually come this way. Okay. And we have put in quite a lot of generous breaks just to cover these kind of eventualities, which is why, we are already 10, 15 minutes behind. But because the breaks were already so long, hopefully we can use some of it to cover the lost time. But really what we don't want to curtail is the interaction. That's the main thing. You are here in person. We really want you to engage and interact with each other and come back with new ideas and new suggestions. And of course, make new connections while you are here. So with that, I think I'm going to pass over to Matteo and let him tell you a few more things about the logistics.
So yes, and thank you to be here. And I will just cover the logistics. So the first things is that we have electric power plugs just in front of your seats on that there should be there. Okay. So the Wi-Fi connection is at the moment eduroam, but we are working for having to let you have the Wi-Fi connection even in the afternoon. And here some logistics. We are in that building there, the green one, okay. And room A, it's in ground floor. It's the parallel room, and this is the plenary room, which is the first floor. To the left here, there is a kind of support room. If you want to work or something, there is a classroom for you in the nearby building, okay, in the second floor. So you just have to ask to the desk and they will bring you to there if you need. Then there will be the coffee break. We have just to go outside and have the coffee break in the other blue building and outside there. Okay, so you have the chance during this symposium to visit all Padua, because we have different sites for different kind of events. So you can get all the position directly in the web page of the symposium, and we are in that red star there, okay, and all the plenary and parallel lectures will be done there, and then this evening we will go here in the Hero, which is a restaurant. It's everything. It's by walking, but in this case, from here will be more or less 20-30 minutes, okay. And then the other blue point there, it's the place where we will have the poster session and even the Wednesday evening event with next footprints on the moon with Matthias Maurer, which is the astronaut that we have the honor to have here with us. And so I think I've done. I've said everything, so I can pass the, I would say, the floor. I can give the floor to the more, would say, institutional welcome from the University of Padua. Okay. Okay. So.
Okay, so everything is currently, hi, I'm Anna. I bombarded you with tons of emails. Everything is live streamed at the moment in the YouTube, but that will disappear. However, everything is also recorded and will be uploaded online. Unless you want that, please reach out to us and say, well, no, opposite. If you don't want to be online, please reach out and tell us that you don't want to be uploaded, and then we will remove that part. Otherwise, everything else will be online. And another important thing you wanted to mention, Matteo, is that everyone needs to bring the badges to the social dinner tonight.
Yes.
Okay, that's another.
Lot of things to.
And everyone who needs a certificate of attendance, please reach out to the luck guys downstairs. That's it.
Thank you. Thank you. Thank you very much. So, Gianpaolo Piotto is the head of this in Athenaeum Center that is in charge of the studies and research and technology for space in the University of Padua. So I give you.
Yes, good morning to everyone. Thank you for coming. We are really many, which made some challenge for the Jesus to organize everything, but we are really happy to see all of them here and welcome you in Padua. I'm welcoming you on behalf also of the rector of the university and as the rector of Jesus that is organizing this meeting. Jesus is the center of the university for space studies and activities, created in 1991 with the specific purpose of helping the collaboration among the different departments of the university, the different groups working on space activities to organize their activities, to prepare the grant requests, and so. So it's a center that is specifically devoted to the space activities, and in particular in the last period there are many projects that are devoted to lunar and Mars exploration, both from the technological point of view, from the exploration of from the geological exploration, thanks to the group of Matteo and his collaborators, geological explorations of Moon and Mars, but also activities related to the human activities in space and all physiological, biological, and also psychological problems related to long stay in space. So we are happy to have all of you here. We are in Padova. This symposium is dedicated to the moon. I need to remind you that the first exploration of the moon with a telescope was done here in Padova by Galileo. And many of you, I'm sure, knows the drawing in his notebook of the moon, which was the first real exploration of the moon. So after 4 years, I think it's really interesting to have so many people. This happens in many other meetings after pandemic, but this is particularly populated, and I'm sure that the feeling that we have in Padova, who will come to the astronaut presentation, I'm sure we'll have also the possibility to see the desk of Galileo, from where Galileo was teaching about his first exploration of the sky. Of course, not only the moon, but Galilean, what we call now Galilean satellites of Jupiter, and many other discoveries. So you will have also the emotion to see the desk from where Galileo was teaching this. But this is just a stimulus for all of you to be in presence here, to chat with each other. And I'm sure this is the best way to foster new ideas, new projects, and new collaboration. And I agree with Matteo. Please explore Padova, because it's a small city, but full of interesting things to see. Welcome to everyone, and have a good work, a good meeting. Thank you.
Thank you very much for that kind words and for encouragement for us to explore Padova. So we are going to start the first session of the meeting. Now, even though we have 10 minutes allocated to each representative who is here, you don't have to take the entire 10 minutes, because the you knew that was coming, right? But because I think, first of all, those 10 minutes will not do justice to what you are here to say. So I think you need much longer than 10 minutes. So the idea there was to gather together representatives of various space agencies, those who are able to accept our invite and come and share with us what's happening in your corner of the world and how that might work together as an international collaboration. So really, there are only a couple of things that as a community, we would like to hear where we are going rather than very specifics of what may be happening. I'm sure there's a lot of activities that are taking place everywhere. And those of you who have eagle eyes might have noticed that actually we are in Europe, what we don't necessarily have every European or space agencies of various European countries represented. Well, there is a reason for that, because for that we would have needed the entire day, because we have 22 member states for European Space Agency. So when we were planning this session, we thought, why don't we hear from the European Space Agency as a sort of a mouthpiece of what they are planning to do about the moon on behalf of various national space agencies who have their own programs in addition to getting it through ESA. So I think this is just a trial. So please, don't feel that we are not bringing all the space agencies to you. And I think I'm not putting any more pressure on our next speaker. Let me introduce Dr. James Carpenter, who will be giving us a preview of what's happening in the European Space Agency, which is our home agency, so to speak, in Europe. So, James, over to you.
Thank you. So, Mahesh has given me a big challenge there. So I'm supposed to reduce to 5 minutes, something like that, and represent 22 countries all at once. So tell you what, let's forget the slides, because that's not going to work, is it? So won't do slides. So first of all, this is extraordinary, right? So I remember the first few European Lunar Symposiums, and they were fantastic, but this is huge. Good luck with the timekeeping. That's going to be hard. And I think it represents, doesn't it, what's happened on the moon, around the moon in the last few years. We've gone from something which was, I think, at the fringes of exploration to being something which is growing and is huge. I think what we're going to see in the next few years is going to blow people away. If people aren't already aware of what's happening around the moon, they will be very, very soon. And so the same things, I think, has been reflected in the work that we've been doing in ESA in the last few years. So we are now developing our first payloads to go to the lunar surface. Those payloads are looking for making measurements of the lunar environment. We want to understand the environment at the places we go. We want to understand the effects of those environments on technology, on people, on the biology on which we depend. We want to understand the origins of life. We want to understand where life is in the solar system and the context for that life there. We can learn a lot about that on the moon. We want to understand the possibilities that the resources of space might offer for us in the future. So to understand what those resources are, where they are, and how we might use them in the future. And we want to open up the destination of the moon and other places that we're going to go in the solar system for research and human activity and for science in the future. Now, we're going to do that through partnership initially. We're working with many international partners, with the United States, with Japan, with China, with others. We're developing new partnerships. We also have an ambition to go from where we are today in Europe, where we have a dependency on others for our space exploration programs, to a situation where we have more and more independence or non-dependence, where we're able to collaborate with international partners, but to do so from a different position where we have our own independent capabilities. And this is the direction of travel that we're trying to bring to realization. So at the moment, our program for lunar exploration includes contributions to the Gateway. So the Gateway is an orbiting outpost, which is being built by an international consortium of the United States, Europe, Japan, and Canada. The first modules for that are going to be launched in the very few years. We have the first scientific instruments for those modules are going now as well, being prepared. We have our payloads going to the lunar surface on international partner missions. And I'm sure you're going to hear a lot about some of those during the next few days. And we have just started now the development of what we call Argonaut, which is the first European lander, be a cargo logistics lander, able to take more than 1.5 tons to the lunar surface. And the first few missions of Argonaut are going to be there to support the Artemis crewed missions. And we're discussing with NASA at the moment about how that might come together. And so the opportunities for science in the coming years are going to be on contributions to partner-led missions. They're going to be contributions to the Argonaut lander, so having payload allocations for Europe on the Argonaut lander, alongside cargo which you provide for the Artemis missions. And we're looking to build a partnership where we have European activity taking place as part of the first Artemis crewed missions to the lunar surface too. So this is the scope of what we're going to do. Now, I wanted to say, I know a lot of you have been involved in the last years in supporting us through scientific topical teams, through mission studies, through payload studies, through providing consultation to us in a lot of different areas. And I know a lot of people have done a lot of work. This is enormously important work and we're grateful for it. Now, what I can say is that a lot of those things, I don't have time to go through all of them because I've only got like 2 minutes, but all of that work was within a certain context of what we expected the program to be. I can tell you that the outcomes of all of that are being used. So when we talked about a biology laboratory on the moon, the work we've done there, the work that you have done there with us has put us in an extremely strong position to prepare what I'm confident will be a biology laboratory on the moon that's going to come. And we are now in a really strong position to prepare that, and we are working on that. There's been work done on a far-side lunar radio observatory. We know now, I think better than anyone else in the world, what it means to build a far-side lunar radio observatory. And that information, that technical and scientific basis that we've built, it gives us a really strong position for the preparations that are going to come within ESA, working with international partners and preparing things in an international context. And we are working on that now. Likewise, for all the other areas we worked on to with geology, geophysics, resources exploration, all of those things are now feeding into the program and in the international discussions that we're happening. I don't have time to talk about all of that now, and some of it I can't tell you, but really appreciate all your work. And you can come and talk to me at any point during the week, and I'll tell you everything I can about where we are and what's happening next. I don't have much time now. But what I just want to leave you with just the idea that I think that we are in an extremely exciting time. Our program within ESA has increased in scale dramatically over the last years. That's very exciting, and we are extremely grateful and happy working with our member states and the support that they've given us to grow that program so that we can work for them to deliver this program for them and ultimately for you. So thank you very much for your time, and I look forward to speaking to you, all of you, at some point over the course of the next few days, and have a fantastic Lunar Symposium. Thank you.
Thank you very much, James, as always. James just is, whenever he speaks, he inspires me, and I hope that he has just given you the flavor of what's happening in Europe. And I said, I can only apologize that there isn't enough time to hear about all the wonderful things that are going on. And I know I said that the home agencies, so to speak, national agencies aren't represented, but there are always exceptions. And the exception in this case is that we are in Italy. So we have to hear from the Italian Space Agency what's going on in Italy. So I think our next two speakers are from Italian Space Agency, from ASI. So could I invite my co-chair, Matteo, to introduce the two speakers. Matteo.
Yeah. So I would say it's a pleasure to introduce here the representative of ASI, which is the first talk would be by Mugnolo. Okay, which is in charge for robotic exploration for ASI. So he will talk about you can stay, and he will talk about what are the plan for the Italian Space Agency about the exploration program on the moon.
Okay, good morning, and thank you for coming. I will try to do a very short overview on what Italy is doing in the context of human and robotics exploration, in particular for what concerns the lunar context, which is the main topic of this meeting. So let's just start with an overview what Italy does in the space activity, and I would like to underline what is the percentage of the investment that Italy is doing in human and robotic exploration. If you see the blue sector here, you can have a picture of how much we are investing, how much we trust in this kind of activity. So the exploration program is organized in three main areas. The first is, of course, to sustain the ESA exploration program, since we are one of the major contribution of ESA. The second is to promote international partnership. That means activity which does not belong into the ESA framework, so mainly devoted to other partners. And the third is about the national activity, which are planned to support, of course, the international context, but also to improve the national competence in technology and science, of course. For what concerns the ESA exploration program, this is organized in 4 main cornerstones. The first is related to the ISS. The second is Human Beyond LEO with the Lunar Gateway, and this becomes to be interesting for the lunar context. The third is specific for lunar exploration program, and the fourth is about the moon, the Mars robotic exploration program. For what concerns the activity mainly related to the lunar context, I would like to underline what Italy is doing for to build this international lunar orbiting station, the gateway. We are contributing mainly to the pressurized module of this station, both habitable module or logistic module, and this is thanks to the great experience that Italy gained in developing of the International Space Station, which most of the pressurized module have been provided by Italy. So we are providing this contribution mainly to the IHAB, which is the International Habitation Module developed by a partnership among the world, and also to the Esprit module, which is the European one. So for what concerns the European service module, as I said, we are, these are, you can see some hardware already in developing phase in Thales Alenia Space in Torino, but there are also other companies, small company involved in this kind of activity. For what regards the third cornerstone, we wish to become the leader of the development of the European large logistic lander. We confirmed the financial support in order to take the leadership of this development. The selection is still in progress. We think that by the end of summer, we will know if Italy will be the leader of this or not. Of course, this activities opens a lot of opportunity for the science community, because if we at the European level gains the capacity to land on moon surface, we gain also the possibility to bring a lot of payload. This kind of lander could bring around 8 tons of logistic elements or scientific payload. So you can imagine this is a very important step for Europe, because Europe is not yet able to land on moon surface. Another initiative we are supporting since long time, maybe it's well known to the people involved there, is the Prospect mission. This initially was planned to run as a cooperation between Europe and Russia, but then and now is no more possible to go in this direction. So the plan is to fly Prospect within CLPS possibility, flight opportunity. And Italy in specific is involved as a science team, but also providing this drill and sampling system able to penetrate up to 2 meters in icy soil in South Polar region. This is another important step because this will open to study the South Polar region to understand if it is possible to extract resource and so on. For what concerns the international partnership, we are one of the first countries signed the Artemis Accord, and this was a very important step last year in October. And we are promoting also an international Mars Ice Mapper mission in partnership with CSA, with Canada, with JAXA and NASA, of course. The main objective of Mars Ice Mapper is to map the ice resource on the subsurface of Mars in those regions in which is possible to land, and in particular at the depth we can think to extract, so in inaccessible area. For what concerns the moon scenario, as I said, thanks to the Artemis Accord, we are now working with together with the NASA team to develop the architecture of the first habitation module to be placed on the moon surface. If this activity is going to successful to the end, the first habitation model on moon surface will be Italian. So you can imagine the opportunity that this open, because this will be used by the astronaut only for 7 days per year. That means that the remaining time could be used for science opportunity. So for what concerns the national initiative, the destination are, of course, the LEO, beyond the LEO, Moon, Mars, and also exploring the nearest object. For what concerns the activity already started, I just concentrate to the center blocks. We are going to issue to select the contractor which will develop a national concept of lunar surface mission. It could be, let's say, a robotic mission to explore the moon surface, of course, integrated with scientific payload. We are going now to select the science payload which will be candidate for this kind of mission. We received 19 proposals, and the evaluation process will be concluded in a few weeks. One of the, for example, scouting scenario for this national mission on moon surface could be, for example, to explore, to scout particular areas in which it's difficult to go with a human crew. For example, the lava tube, which are many times mentioned as possible site in which to start infrastructure settlement. But we also support the in situ resource in extraction concept to use, for example, regolith for building material, building blocks for construction. And of course, the solar power pilot plant, which is the power is one of the most critical topic to be solved, because the lunar condition, especially during the night, the long night, is very difficult to survive. So I go to the conclusion, just mentioning that we are starting also the development of oxygen extraction demonstrator. We are this activity is already fully funded. We plan to finish this by 27, but it is important to underline that we do not pretend to solve the problem of oxygen extraction at the first shot, but this will get Italian team to gain a lot of experience interacting with the moon surface. And last, I finished, we are developing lunar mission robotic control center, in which it will be possible to test in environment, in controlled environment, those instruments, those elements we plan to run on moon surface using a regolith simulant, using also lunar terrain simulator in order to have a possibility to plan, for example, rovering and so on. And then the Lunar Mission Control Center, which will allow the users, the scientists mainly, to plan their operation, to run in a simulated way before to send them for execution on moon surface. So this is the last slide, in which I tried to summarize what is agency, and you can see here are mentioned all the activity in which we are involved. We play an important role, going from the lunar gateway elements to the moon surface elements, and of course all the communication system, Moonlight, in which Italy is going to have a main role. So I think this is the complete scenario. I hope this will be useful for all of you in order to plan your future science activity. That's all.
Thank you. Thank you very much for this interesting presentation. The question and answer part will be at the end of the session for everybody. So I have pleasure to introduce Dr. Chris Conio, which is the responsible of the Office of Payload, Microgravity Payload and Experiments of the Italian Space Agency.
Thank you very much. Good morning, everybody. So just a moment. Immagino che scorre questo. No, questo qua sotto, oggi su questa parte. Thank you again. So I'll try to give a sort of snapshot on what is going on from scientific point of view in Italy for the moon. So let's start from since James did not show his presentation, I stole a slide from his presentation. So you see some ESA moon payloads, and two of them are Italian payloads. So one of them was already presented by Raffaele, so was lack of coordination between me and him. So I skip this one. Another one is named Moonlight, same name, but different from the communication project, which Raffaele mentioned at the end of his presentation. So is the, let's say, next generation retro reflector that will be launched to the moon with a CLPS mission, so a commercial mission provided by NASA. And the ambition is to give a higher precision in the demonstration of general relativity. So, okay, so sorry. So it will be composed from the retroreflector itself and a dust cover, so to avoid that moon dust can let's say worse the performance of the reflector. Then we have another payload that will be launched to the moon for a technological experiment on the Galileo and GPS. So its name is Lugre, is in cooperation with NASA, and it will assess the reception of GNSS signal from the moon. So to demonstrate if it will be possible to use such data in future moon mission. Then we have a Lumio, a CubeSat that will be launched to a Lagrangian point to observe from that position the flashes caused by the impact of meteorites on the hidden part of the moon. Okay. In addition to these initiatives relevant to moon surface, we were involved in a possible future payload on the gateway in the frame of the ISIS-WIG, which is an international working group on life science, and with some constraints on resources that on gateway are less with respect to the ISS, which we're used to. And so you see a list of possible payloads that will be the first payloads on the gateway. And one of them is developed by Italian Space Agency, is named In Situ. Was chosen because has already flown on the ISS, so it's a, let's say, proven technology, and is a portable analytical device for a biological sample. And currently is under development a new version of this device based on lab-on-chip technology, and the idea is to provide, let's say, medical tools for astronauts in a future mission beyond LEO, when more autonomy will be needed for care by astronauts. This is an activity under ESA umbrella. It's named EFNet, and it's the development of a in Italy data hub of radiation data to support the two radiation payload under development by ESA, who are ERSA and IDA. and then in general, to collect all radiation data from gateway and so on. Then, at national level, just few months ago, ASI issued an announcement of opportunity, a call for scientific proposals, and was focused on three main areas. So the first, power production and beaming on the moon, then studies and modeling of the surface and subsurface of the moon, and third, bioregenerative and waste recycling systems for the moon, which is one of the really enabling technology for a future moon base. Then let me add that at a recent ESA announcement of opportunity for a research pool of moon experiments, 7 out of the 21 proposals selected are Italian. 1 minute, okay? Finally, last slide is on a very ambitious project in coordination between the Italian National Agency for INAF for astrophysics, Italian Space Agency, and Italian INFN, so Nuclear Physics National Institute, and is funded by the PNRR, so the, let's say, special money coming from the reaction to the pandemic. And the idea is to design an observatory on moon surface that will observe both to deep space and to Earth. And the project is just started, so we are in the let's say initial studying and assessment phase. With that, it's all. Thank you.
Thank you very much. As you would have already seen that how many slides actually relate to what's going on in ESA as well. So this is just a beautiful example from one European National Space Agency that how interwoven their plans are with ESA. And imagine if you times that 22, you probably have to spend more than a day. So once again, it just, shows that how much activity there is with regards to lunar exploration. And I think we are going to hear a bit more later on. There is in fact a special landing site related workshop happening in this meeting that some of you are probably planning to go. Let me move on and introduce the next speaker. It's Professor Anil Bharadwaj, who is the director of the Physical Research Laboratory in India, an arm of ISRO. Anil can't be here with us because it was just not possible to organize his visa in a short time frame. But he agreed to actually talk to us about what's happening in India. And I believe something very exciting going to or about to happen next month. So Anil, if you can hear me, the floor is yours, and you have a maximum of 10 minutes. And then if you stay around for a Q&A with the rest of the panel, that will be much appreciated. And apologies for running a bit late.
Thank you, Mahesh. I hope you can hear me.
Yep.
And you can see my slides.
All good.
Great, thank you. And thanks to all the colleagues. Good morning to Padua. I'm sorry I could not be there in person, but at least thanks for allowing me to join this program online. So what I'm going to do in next 10 minutes is to give you an overview of Indian lunar program. As you know that India started its lunar program with the launch of the Chandrayaan-1 mission in 2008. And incidentally, it also had a very exhaustive collaboration with European colleagues. We had 4 experiments where European colleagues participated in it. 2 was European-Indian collaboration, the Chandrayaan-1 X-ray spectrometer and the SARA. And we had a fully European collaboration on SAR2 and add-on. In addition to that, of course, we had US participation in there with M3. There is a moon mineral mapper from JPL and Brown University, as well as MINISAR from APL. And there were 5 experiments from India. So this was essentially meant to do chemical, mineralogical, petrological mapping of the whole moon in the visible, near infrared, and low and high energy X-rays. And of course, to look at in situ measurements. In 2019, precisely to be on 22nd of July, we had the launch of the Chandrayaan-2, which carried 8 experiments on board on the orbiter. And there were other experiments on the lander and the rover. We all know what happened to the landing, but these experiments on the orbiter, 8 of them are working very well and providing excellent quality of data. And I will talk a little bit about that if time permits. We are now having the Chandrayaan-3 mission, which is going to go next month. And this is going to be a lander and rover mission. And I will talk a little bit about that. So talking into more details about the Chandrayaan-1 mission, which of course was truly international, as I just mentioned, carrying 11 experiments on board. And I was directly involved with the experiment called SARA, which stands for Sub-KV Atom Reflecting Analyzer, which also had 2 sensors, SWIM and CNR. And on the top, you are seeing the Moon Impact Probe, which was a standalone satellite of its own, which actually, after we reached 100 kilometers circumpolar orbit, it was released to land into the south pole of the moon, which actually made MIP the first man-made object from India to land onto lunar surface. SARA, the Chandrayaan-1 has brought out excellent science results. And the most important, of course, you know very well, is the discovery of water on the moon, not only on the moon, above the moon and below the moon surface also. In addition, of course, we validated the lunar magma hypothesis. We discovered mini magnetosphere on the moon. And to say that moon is geologically active because there has been volcanic activity happening in the moon in the very recent past, going down to almost 10 million years. And many of these results actually came as a cover page of various journals. So 2 of them are highlighted over here. And since I was just involved with the SARA experiment, I will just give you a glimpse of that in terms of what we knew of how solar wind interaction takes place with the moon, because moon goes around the sun, around the earth, taking about 27.5 days. So about 7 to 8 days, it is inside the Earth's magnetotail and magnetosphere, but rest of time it is outside. And this was the kind of picture which we had before the Chandrayaan-1 of how the solar wind, which is a flow of plasma from the sun coming and interacting with the moon surface. But this whole simple picture has been translated into this complex picture right now, where we know that a very significant amount of physics is going on onto the lunar surface just because of the interaction of the solar wind with the lunar surface. I will not go into detail of this. You can read too many papers which has come out from this. One important one, which I'm just highlighting, which actually became the ESA press release on October 16th of 2009, which suggests that hydrogen offers a new way to study the moon, where we actually see a very large amount of energetic neutral hydrogen atoms coming out from the lunar surface simply because of the solar wind having a charge exchange at the lunar surface, and about 20% of that coming out from the lunar surface. And this is talking about the GRL cover page, which is the discovery of the mini magnetosphere on the moon from the ENA measurements. Chandrayaan-2 is a much more complex and complicated mission than Chandrayaan-1 because it not only had the orbiter like in Chandrayaan-1, but it also had a Vikram lander and a Pragyan rover. And I'm not going to go into details of what happened with the landings, but the orbiter, which was sitting over the composite, which you see over here, had been doing very well. We had a launch on 22nd of July, as I was just mentioning, and 8 experiments on board on this are working very well, providing excellent quality of data. I will just quickly glance through I hope I have still 5 minutes left. So OHRC is one of the very high resolution camera on board, providing resolutions of 25 centimeters at the lunar surface, particularly in the polar regions where we have less amount of data available. And this is now being used for the Chandrayaan-3 landing site scouting as well. We have got excellent data about argon 40 distribution from Chase-2 experiment, and you're seeing on the top how they are quite patchy. We have got much better coverage of lunar hydration, particularly talking about the distribution of water and OH molecules, and excellent information about the distribution of elements on the lunar surface, particularly the magnesium, aluminum, silicon, calcium, iron, titanium, but also about the sodium and distribution of sodium across the moon. We had an experiment called a solar X-ray monitor, which is, of course, one of the best instruments currently operating in space, providing the data on the X-rays from the sun, which is essentially required for doing fluorescence on the lunar surface. And this information is coming every 1 second for energy range of 1 to 15 kBs. And excellent science has come out, even talking about the discovery of micro flares on the surface of the sun, even during the deepest minima of the last centuries. And the dual frequency radio science experiment talking about a very large amount of ionospheric presence in the wake, or I should say across the terminators, which has been discovered by the plasma experiment on the Chandrayaan-2 using a dual frequency radio science experiment. Right now, we are working over Chandrayaan-3 mission, which is going to be a purely lander and rover mission, duplicating more or less what we did in the Chandrayaan-2, but of course with much greater and enhanced technological capabilities. So we had a lander, which is named as Vikram, and the rover, which is going to be coming out after we did the landing, called Pragyan. And this is going to go next month, mid of next month, that is July, where we are going to go to the moon to 100-kilometer circular polar orbit after the launch and all those maneuvers, come down to 100 by 30 kilometer, and then descend into the polar regions. We have 4 experiments on the lander, the thermal probe, the Langmuir probe, the seismometer, as well as a lunar retroreflector from NASA. And we have 2 experiments on the rover, alpha particle X-ray spectrometer and laser-induced breakdown spectroscopy. And so we have experiments on the lander as well as on the rover, and they will provide us a lot of in situ measurements in the high latitude regions. So this is just a cartoon which I just copied today for these presentations, talking about the whole mission. About 4 tons of kg of the total mass of the spacecraft will be going to the lunar's 100-kilometer circular orbit, and then the lander, which is about 1,700 kgs, and the rover, which is about 26 kgs. And they are going to work on the lunar surface for a lunar day, which is like 14 Earth day. And we hope that in case they survive the lunar night, then we can have much more lunar days of observations. So where we are landing into the polar regions of the moon. You see in the down the orange colors, where we have the primary and alternate landing sites. So this is the region which has not been explored so far by any landing missions. And that's why we are going to see something unique and new. We also are working on a collaborative mission with the JAXA, Japan, on LUPEX, which is basically a lunar polar exploration mission, where the focus is essentially to look at lunar polar water distributions or the other volatiles and elemental composition of the lunar surface. And this would be a mission where India is going to provide the lander, and JAXA is going to provide the launcher as well as the rover. This is still in preparation. A lot of discussions are going on with in ISRO and JAXA, and hopefully you will hear something much more concrete on this in the next year or so. So with this, I would like to thank you all for listening patiently, except to tell you that if you are interested to look at any of these data sets, which is there from the Chandrayaan-1 or Chandrayaan-2, you can come to this website, which is accessible for all the public across the world. Thank you very much for listening patiently. Thank you.
Thank you very much, Anil. I'm sure there are plenty of questions for you. We are all going to be rooting for, of course, Chandrayaan-3. And as we were for the iSpace lander, which unfortunately didn't succeed in its final hours. But nevertheless, we have the pleasure of hearing from the representative from the United Arab Emirates. And I'm very pleased to welcome Sarah Al-Maini, who is going to be telling us about UAE's plans. And I'm sure she will touch upon a few other things. So Sarah, over to you for next 10 minutes.
My name is Sarah Al-Maini from Hamad bin Rashid Space Center, and I'm here today to talk about the Emirates Lunar mission. So I'll skip some slides and talk about the mission. So the mission consists of a small rover called the Rashid rover. This announcement was made in 2022. We had different primary objectives. The first one is to have the technology demonstration of building a rover for the moon and do some fundamental science that will help us in understanding the geology of the moon and will help us in future missions. Also, as like secondary objective, we had to attempt to survive the night and do some public engagement during the operation of Rashid rover. Talking about the fundamental science, we wanted to understand the soil surface properties, to understand the altering processes of the lunar surface and understand the big question of what is the formation of the Earth and Moon system. Also, we want to understand the plasma environment and especially the electron sheath, the vertical distribution of the electrons at different heights, and understand the dust transport from a place to another. From engineering aspects, we were doing we had one experiment called material adhesion determination experiment. Where we wanted to understand what is the interaction between the soil, the regolith and different materials. And this was based on one of the experiments we did on the wheels. For the mobility, we wanted to understand what is the interaction between the wheels in terms of sinkage with the lunar regolith. To fulfill all these science objectives, we had different science instruments, starting from the Langmuir probes that we have on different heights on the rovers. We have also thermal cameras to understand the thermal behavior and of the rocks and the boulders. We have two cameras. The cameras, of course, will used first for the navigation, but also will be exploited scientifically. We have also microscopic camera. The resolution is very high, can go down to -30 micrometer. And finally, the material samples here on the wheels that you see here that conduct the experiment with the lunar regolith. Of course, the rover went through different testing and verification, qualification, starting from mobility, communication, drive-off, environmental, consisting of thermal, of vibration, and finally with the integration with iSpace lander. So the plan was set to launch in 2022, as you saw last year. And it took around 4 years of trajectory to be on the moon. And unfortunately, on 25th of April, a crash landing happened. We didn't deploy in the moon, but there is a real success that lies between the missions where we had a numerous collaboration with agencies research centers and entities around the world. For the science itself, you can see from here that it's more than 15 entity. We had this collaboration, and of course, from other aspects like the landing site, ground network support, we had other collaboration. So for the first one, it was landed on Atlas crater. More information about the geology of this Atlas crater will be given by our colleagues from CRPG tomorrow. And what is next? So next is South Pole, of course. It will give us the opportunity, as you know, to access this permanently shadowed area and maybe we can find some, we can see the presence of some volatile substances. So the plan is like as the follows: is it's planned to be at Q4 2026 to have the flight model, maybe to launch on 2027. We will have also again a commercial lander. The science again to do some water prospecting, and the duration is 50 days. So the strategy is to chase the light, chase the sun, and fulfill this objective. The mass is somehow same. It's still a small rover. It's around 25 to 30 kg. So I made it very quick, and this is from my side. Thank you.
Thank you. So I introduce Kyungjung Kim. Hope to have pronounced it right. I would say from KIGAM, Korean Department of Geoscience and Mineral Exploration.
I can sit down. Yes. I'm from KIGAM. This is the under Ministry of Science, Technology, ICT. This is government organization. Under that, we actually have several, actually 22 national institutes. KARI and KALSI and KIGAM is one of geoscience and mineral resources. So we have a different expertise. So I'm not, at the moment we are planning LUNAR mission for lander and other things. So I'm reluctant to say, so I minimize my talk in what I've been involved in as a KIGAM employee. I'm sure everybody knows about KPLO by now. So it has launched August 5th Korean time last year. And then it took about 4 months and 3 weeks to reach the moon. And now successfully for several months, we are on the moon, and all the data collections are very successful. And originally it was for one nominal mission to be 2023, but many results are very, very good. And we proposed to extend the mission to be 2025. This will be announced by today in Korea officially. So I would like to mention about KPLO gamma ray spectrometer. Especially this spectrometer is very interesting, and then also giving out more result than we expected because of time was very interestingly, we actually designed the instrument, and then the result was really surprising. So detection of the gamma ray burst 221009A, it was a historical gamma ray burst, and that we measured.
And monitoring of a solar flare is very important because right now we are reaching toward solar cycle 25. Because of these activities, lunar radiation environment, we especially can have the mapping for radiation environment mapping can be possible. And in most cases, lunar mission was focused on lunar mineral mapping and for lunar geology and resource prospecting. But we actually did one to three, we cannot say like accidentally, but because of time, we are doing this kind of science very heavily right now. So KGRS is located in, you can see in the center, the yellow, the circle, and the electronic box is inside. So this was made in lanthanum bromide, and then I put boron, 5% boron loaded plastic insulator. This actually works as a neutron detector. And it is the lightest instrument as a gamma ray spectrometer for planetary investigation, 6.3 kilogram, and the collection times 10. And we are able to measure X-ray, gamma ray, and neutrons. This is very interesting way that we can do lunar studies. So I will introduce the result. So this is the gamma ray burst 221009A, and the location, you can see the pink blinking. That is the location where we got where the gamma ray originated. So it is about 1 in 10,000 years. It's very rare and it's very strong. It came from far away and about around 2 billion light years, and then actually started from that because of light, right? And because we have a very narrow window. So there's a location is a Sagitta constellation, and we have only a narrow region, time window to measure this gamma ray burst. So I will prove how this was strong with our instrument. So actually, I was so excited about this, and you can see the trajectory, and it was the farthest distance we can go is 1.55 million kilometers, but the measurement was done at the location of 1.51 million kilometers. And by looking at the magnitude, it's about 98 times, but if the summing, it is much higher. So because of this situation, actually I made five gamma ray channel, like X-ray regions and low energy gamma rays. And then also the total count of the lanthanum bromide, we have a low gain, high gain, and then BLPS, that's a neutron can measure. So we have actually 8 channels can be used for counting, as a counter. So here's the data. You can see not only just like a very narrow the counting data. This is actually spectrum. So from the 0 to 7 MeV spectrum, summing it, then you can see the bottom one is actually, this is the background. In the background, the lanthanum bromide had the intrinsic spectra, and the top one is actually the first arriving. You can see the very bright one is you can see that's top one. And then later on, we have a small burst coming again. So actually that from the background level, the first gamma ray is actually 1,000 times 479 bright, mainly higher. So this is very quantified data we provide. I don't think this kind of data have done by gamma ray spectrometer before. And if we compare with this Fermi data or publication, exact time is really interestingly, we recorded this about the core time is about 6 minutes, and then you can see how we can compare with other data. And also ionosphere, and also this ESA, there's a ESA measurement was done, and they all matched well, and we are very happy that the KGRS had this kind of historical data. Another exciting moment is coming recently because the solar cycle 25 is exceeding predictions. We probably previously thought that the blue line was possible way, but now you can see it is already going toward the higher the altitude, I mean the magnitude here. So if we think about the solar, the sunspot number, 2023 about 150. So which means by 2025, it will be much, much higher. So that is probably going toward the top curve. Yeah, this is actually, I wanted to show, just feel about what is solar minimum, what is solar maximum. So it's like 1 minute more. So KGRS, KPLO will be extended, the mission will be extended until 2025 December, which means we can cover solar cycle maximum and a little bit further. So we're going to have a very interesting data coming in few years time. So this is another exciting data. This is the NASA's the image, and then also NOAA data. You can see the red, red circle, I mean, coming out, that is March 13, 14, 15. So it is a coronal mass ejection coming. So what is coming out is actually, of course, gamma rays, but it is actually protons coming out. So anyway, so we are checking this kind of space weathering data together with our data. And our data shows September 2022, October, February, January is a little bit lower, more likely the X-rays and gamma rays, and then very, very minor. And then March 13, 14, 15 is very high. And then May 9 also we had. So if we look at the data, I'm sure everybody knows that the solar cosmic rays constitute of mostly protons. So across 90% of protons coming, but the energy is very low. Like you can see the top curve is actually 10 MeV line, and the other one is 50, and the green one is actually 100 MeV. So we measuring protons flux by NOAA, and then the right side of KGRS is measuring the top surface, top graph is actually the gamma rays, channel 1, 2, 3, 4, like X-rays and low energy gamma rays, and the bottom one is actually total count is like up to 7 MeV, 4 MeV, and then the green one is actually neutron count. Yeah, neutron count. So this is very interesting way that protons coming in, and what we see is actually this kind of secondary neutrons and the other gamma ray and X-rays. So there was the warning around March 13, 14. So that was the exciting research going on at the moment. And I could say preliminary result of KPLO-GRS. So at the moment we are making the preliminary actually map. So I'm not able to go details, but you can see Chang'o data and then KGRS. The bottom one is KGRS. So we have deep space background measurement and background measurement on the lunar surface. And you can see the low energy. We see the spectrum for low energy. So that is one difference. Sorry. Yeah. So yeah, we'll continuously produce maps based upon this. So hopefully our map can be utilized for future lunar investigations and the Artemis program. And previously, our team have used gamma ray data and M-cube data together with Clementine data to see how we can use the image and gamma ray data to understand the surface lunar geology and resources mapping. So this will be continued. And the Korea has announced that we're gonna have lunar lander by 2032. The Korea is focused on launch vehicle capability, and then lander and the orbiter, and then all necessary astronaut training and the lunar base and mobility and deep space network and things like that. So this is very actively working on by the government, and then all national institutes are working together. For Korean National Institute for who focus on geology and mineral resources, especially payload development and then resource assessment, and then resource administration and resource extraction and utilization. So I'm waiting for 32 lunar lander participation, and we'll focus on resource extraction. There is a lot of activities are going on. Of course, the Korea signed for Artemis Accord as a 10th country. We are eager to do international collaboration. I think this is happening right now. So I hope this time I could have some connections with anyone who are interested in collaborating with Korea. So this is, yeah, funded by. Thank you so much.
Now, Dan Bloomberg, the chair of Israel Space Agency. So we'll talk about the plan of the agency.
Good morning, almost good noon. Welcome to all. It's a pleasure to be here. My name is Dan Bloomberg. I'm chairman of the Israel Space Agency. My background is planetary geology. I have to say, not the moon. Most of my work has been Earth, one of the planets, Mars, Venus. But I'm happy to talk about our plans for the moon over here as part of the Israel Space Agency. First of all, I'll say that we signed the Artemis Accords. We're part of the program. We're also involved in Artemis, and I'll show you one of the examples as I move along. I was about to hide some of the slides, but the menu's in Italian, and I wasn't sure there. So I'll just skip slides as I move along. I apologize ahead of time for that. And why am I not moving? Yeah, I was going to start off with this slide, which I always like to start off saying that, you know, remote sensing is not something new. We've been doing this for quite a while, and I have a lot to say about this pigeon in the picture, but I won't do that. I'll give a talk later on about pigeons and space. Israel is a relatively small country. We have a long legacy with space missions, launching, actually building, launching, operating, and eventually taking them from womb to tomb. Our first satellite was launched in 1988. Since then, as you can see over here, we've launched quite a few satellites. There are actually more than are on the slide because in the last 2 years, we've launched quite a few more satellites. The two that I wanted to mention started off with 1988, starting our legacy, and 2019 was the Bereshit mission to the moon. Our first mission that we operated going out of, not looking at Earth, out into a deeper part of space. Bereshit, by the way, means Genesis. I'll say that. I'll get back to Bereshit in 1 second. I'll also say that the space agency itself is a lean space agency. I work at a university. Most of our employees or members of the agency work at universities, and all of the operation is done through nonprofit organizations or academia. I'll skip that one also because everyone is in this room. You all know who's been to the moon, and everyone's been talking this morning, and I thank everyone that spoke this morning. So I'll start off with this picture, 2019. Some of you will probably say that Bereshit 1 was a failure, a disaster, but I want to say there were two objectives. One was get to the moon, and the second one was hop on the moon. We did both of those. The hop wasn't exactly what we had planned, a little harder landing than we had planned, but it was achieved. This is a picture, a true picture from Bereshit 1, taken during the landing. We have quite a few more pictures. I like to show this one to show that we actually took these pictures. We have another one of the lander as it goes down with some text that was on it. I'll skip that and I'm going to go and say with Bereshit 1, we started. That's not the end of our program to the moon. So now we're planning on going on to Bereshit 2, another lunar mission, another educational program. So Space IL is the nonprofit organization that was founded by 3 young engineers sitting in a coffee room, looking at the Google X contest, pulling out a napkin and starting to draw a lunar lander on that napkin. By the way, I'm from Ben Gurion University. I have to say, 2 of these engineers are graduates of Ben Gurion University. I just had to say that. I get paid based on how many times I say Ben Gurion University. So the mission ended, Bereshit 1, on April 11th, 2019. By the way, during EGU of 2019, but that's not the end. There were several achievements in Bereshit 1. First Israeli spacecraft to go to the moon or go beyond Earth. The 4th country to touch upon the moon was a lander. 7th country to capture the moon, first capturing photographs. First non-governmental organization to fly to the moon. And you know, there's a lot of pride associated with it. I think that the best part of it is the kids, the thousands of children that were involved in the planning, in learning, and we try to inspire them with this mission. I mentioned there's another photograph with some text, and you can see over here, small country, big dreams. That's also a picture taken just before the crash on the moon. You can see the lander over there about to touch. So I said Bereshit 1 is the end of 1 and the beginning of 2. So we're going now on to Bereshit 2, which goes on from where the previous mission ended. Bereshit 2 will look slightly differently. It's planned to be a 3-part mission, an orbiter and 2 landers. 2 landers that will be released from the orbiter, landing on 2 separate locations on the moon, a longer mission than Bereshit 1. Each one of the modules will have scientific experiments. Most of the experiments have been selected already, not all of them. There is a funding issue that we're still dealing with. There are any philanthropists in the room? There's a box over there to put the, but we're getting there. We also want this to be a global mission. We want other partners in this mission. We're going to keep children involved, kids. The plan is to have them involved in the mission itself as part of the controlling of the orbiter and taking pictures while it's up there. And that's part of the plan. Now we can say double, triple the effectiveness, whatever number you give over there is probably true, but that's the objective. We want to do more than we did in the previous one. We want to open it to more international partnerships and give the partners a strong hand in controlling the mission. So a little bit about what's going to happen on Bereshit 2. The landers are going to be the smallest landers ever. You'll still see. They'll be a little bigger than CubeSats. We're already designing them. There'll be a control room where children can be involved in taking pictures on the orbiter and a few other things that will happen. Just to give you a feeling of what the plan is, you have this slide over here. Said I'm going to run through a few of the slides. Few of the experiments. One is a biopharma experiment on drug stability in deep space, important for the Artemis missions. This is run by the Hebrew University in Jerusalem. They're going to have a spectrometer within the Raman spectrometer on the mission, and they're going to be testing drugs. Again, I said I'll mention Ben Gurion University. This is a hyperspectral camera that we designed using compressive hyperspectral sensing, which means that we can reduce the size of the hardware dramatically, and it'll be designed to fly on the orbiter and take hyperspectral images of the moon's surface. Another one is a seedling project run by 3 Australian universities, where they're going to test the seedling of seeds on the moon. I'm running. We signed an MOU with NASA to be part of this mission recently, by the way, in January. DLR are also now involved in collaboration with us on Bereshit 2. I want to skip to 2 other things. Radiation is a concern for any human flights to the moon. On Artemis 1, I'll be 1 minute. Artemis 1, we had an Israeli radiation vest designed by the space agency and STEMRAD, the Astrorad that actually flew already on one of the dolls, whatever you want to call them. And we're examining the results at the moment. It's extremely lightweight, protects the bone marrow on the astronauts. You can see the pictures. And another experiment is the Hoppler, which is a drone that can be flown into the lava tubes in the moon of a company called WeSpace in Israel that we're funding. So that's the design. It can actually fly. And I'll stop over there for the sake of time.
Thank you very much for this beautiful talk and the educational perspective. And now it's time for JAXA with the Deputy General Director, Masaki Fujimoto.
Hey, Masaki Fujimoto. I'm the Deputy Director General of the Science Institute of the Japanese Space Exploration. So let me try to explain what the JAXA's plans of Moon to Mars. First, we do have a human exploration people, and they are really focusing on this big things, direct contribution to the core part of the Artemis, like rover, robotic rover to the southern pole, and then providing the pressurized rover in late 2020s. But that's coming from the Human Exploration Division. And I myself is from the Science Institute. And we are really interested in this one. Yeah. Robotic mission and OK-sized robotic missions so that we can fly them more frequently. And we are starting from a mission by the name SLIM. This is going to be launched soon. And this is a small lander with two special features: pinpoint landing, 100-meter-ish landing ellipse, and then a two-stage landing scheme. What you're seeing here on the screen is the way that the spacecraft clinches to the surface of the moon so that it's capable of landing on the rough terrain, I mean, like a slanted area. And then we also are trying to set up a new program by the name LEAD. This is to gain our technology to explore on the surface of the moon with an OK-sized rovers. And it's also driven by top science themes like radio astronomy, lunar science thermometer network, and then the sample return mission. So this is going to be a precursor to a frequent lunar exploration that will involve multiple assets provided by multiple partners, including commercial sectors. What I mean by this is that this is going to be an OK-sized mission. This is going to be a precursor to the OK-sized mission that will involve many people. And the reason why we wanted to have this line in lunar exploration is that unless we have this kind of OK-sized mission line on the surface of the moon, unless we gain experience with these kind of missions on the surface of the moon, we will not be able to get the step towards Mars. But thankfully, we are moving on with this LEAD program, and that will enable us to plan our Mars landing program beyond MMX for the sample return mission. But how do we even think about landing on the moon now that, well, other big agencies already have performed things like this? The key issue is that we have the key technology. In the Martian tenuous atmosphere, you don't have to always bring big hard shell to bring your asset to the surface of the Mars. If you're interested in lightweight access to the surface of Mars, inflatable soft air shell works. You don't have to, because the atmosphere of Mars is so tenuous. There, you have to worry about the speeding down, slowing down the descent, not too much about the heating upon entry. So inflatable soft airship is the key technology if you're interested in lightweight access to the surface of Mars. And we are interested in lightweight access to the surface of the Mars because our launcher capabilities is limited anyways. So the plan now is to have the 3 steps, much synergy with the LEAD program, the Lunar Exploration Program. And we also wanted to have this as a springboard towards a new way of performing deep space exploration as well. So the broader background of what I'm saying now. Nowadays, we're interested in space. I think we're really starting up a new era of space exploration, and many are willing to be partners. But on the other hand, when you talk about Artemis, we tend to talk about just big things, and everybody's get like, oh, what can I contribute? But maybe if somebody provides an OK-sized robotic missions within this Artemis framework, that will be a nice entry point for everybody to join. And then maybe, so what I'm saying is that somebody might want to set up a nice platform where everybody can join. And OK-sized mission is the keyword in thinking in that line. And nowadays, small assets are becoming capable. So you can think about the constellation of CubeSats to perform heliophysics observations, to perform something for planetary defense. But something more relevant to Artemis is to think about a mother spacecraft system that assembles multiple small assets and bring it to Mars orbit to perform deep space exploration. And that is our Mars landing program is exactly in that shape. orbit transfer vehicle bringing multiple small assets to the orbit around Mars. Some of them are small landers for tech demonstration to be performed in late 2020s. And well, it's in that shape. So another spacecraft system bringing small assets and to perform deep space exploration. It's better to have that mother spacecraft system to be exactly the same design for various deep space exploration, so that our emerging, our new partners, our newly emerging partners will find it easy to join in the future opportunities. And maybe, so this is really like setting up platform for deep space exploration for all, and maybe giving where we stand in the global landscape. We could be the one to lead this activity. So take home message that JAXA does have a human exploration division who's really doing those big things, but we from the Science Institute are interested in an OK-sized mission. Lightweight access to the surface of Mars is what's driving our activity. And we do have a lead program, a program to set up an OK-sized mission series on the surface of the moon. That's all I have to say. Thank you.
Thank you very much, especially to those speakers who are actually saving plenty of time for the panel discussion. Hopefully, I'm sure there are plenty of questions, and coffee will be arriving soon, so don't worry. I think it's only Greg who stands between us and the coffee, but but it's my real pleasure to hand over the mic to Greg Schmidt, who is the director of survey, and he's here to tell us about what NASA is planning. And I'm sure that he's not going to use his slides by the looks of it, but it's not just about Greg presenting about NASA. And I wanted to also mention that we are here probably because of Greg, because without his support when he started with NASA Lunar Science Institute, when we actually conceived the idea for European Lunar Symposium, we probably wouldn't be standing here for this meeting. So Greg, over to you.
You're going to get me all choked up here, Mahesh, to start with. So
What's your presentation title?
I don't have a presentation, so we're all good. Yeah, I stand between you and coffee, as Mahesh just mentioned, and if you're feeling like James Carpenter and I are right now, you're low in blood caffeine right now. So I wanted to say, first off, it is so good to see everyone and to see so many more of you this time, and to see so many young faces in the audience. This is just fantastic. You're going to hear a lot from NASA during the next 3 days. So I'm really going to focus on survey here. And I want to take us back to 2010. And to a meeting with, we were called the NASA Lunar Science Institute back then. And we had a very small meeting at LPSC that I know a number of you are very familiar with, and probably much of the audience here. The meeting was Mahesh, myself, Wim van Westernen, and Ralph Yauman. The last three were our only European partners at the time. We now have 5, and we're actually talking with 4 more. So in the coming couple of years, under Christina Gibbs's leadership, we may have up to 9. And we talked about an idea. We talked about an idea of a pan-European lunar science consortium, and with a meeting associated with it, and so much, large part to Mahesh's hard work, plus the work of our other partners with us supporting it as much as we possibly could. We had the first meeting of the European Lunar Symposium back in 2012 in Berlin. At first, it was every 2 years, but I think in 2014, we decided there was so much interest and such a growing interest that we would have it every year. We've been so honored to support this ever since. We have 5 of us here from Survey. I want to introduce Christina Gibbs, my deputy here. Brian Day in the back, who's our acting chief scientist, head of solar system treks, and then Ricky Guest here, who's running tech, and Marco Bolt, who I believe is in the other parallel room setting this up. This is underscores our commitment to this meeting, to our European partners, and to all of our partners around the world. So I thank Mahesh and I thank Christina for all they're doing to keep this going. So I want to say that our commitment to the moon is strong. We were renamed back in 2013 to be SURVEY, and what that was a reflection of was the expansion of our interests to both near-Earth asteroids as well as Mars's moons. But for various reasons, obviously Artemis being at the core, we've refocused our efforts towards the moon. And so we've just chosen within the last month or so 5 new research teams. You can check our webpage out for the announcement. And Tom Orlando right there is one of the new selectees, plus 4 others. And these teams are all very strongly lunar focused. And we have become integrated in a way that we never were before, with not just Artemis, but also CLIPS and PRISM and so many other things that NASA is doing. I want to mention that we went through a senior review last year. My 2 predecessors as directors of the Institute did not have to do this. I was the first, but with a lot of help from Christina and a lot of others, we came through in flying colors. You can see the report at the LPI website online, but bottom line, they said that we were a very valuable part of the agency's arsenal for dealing with science-related questions for human exploration. And so we were just extremely gratified to get these results. Like I say, we're more involved with missions than we ever have been before. One of our former survey staff, Dr. Brad Bailey, who I think a lot of you know, is now Deputy Director of SEO at NASA headquarters, which is in charge of CLIPS and PRISM and a number of other things. And so we have an entree there. And then at the very end of this symposium on Thursday, you're going to be hearing from Dr. Jake Bleacher, who was also a former survey investigator, who is the head exploration scientist for all of NASA. And Christina and I are working very closely with Jake to help to have survey be a key instrument for informing Artemis on key science needs. Like I say, you'll be hearing from him at the end of this symposium. So just a couple of more words. I mentioned young people at the beginning. It's been really gratifying. It's gratifying now to see so many young people in this audience. When we started this institute, that just wasn't really the case. We were dealing with lunar scientists who were primarily grew up in the Apollo era, and now a lot of those folks have retired and left the field, and so we saw the next generation as one of our key challenges, and we've focused a tremendous amount of work on that, and it's been incredibly gratifying seeing so many young people go from undergrads to grad students to postdocs and now to be investigators on some pretty incredible missions. I'm looking at a couple of them right here in front, and so it's been fabulous to be a part of that. And I want to say as well that international partnerships are at the core of what we do. I personally started the International Partnership Program when I became director. Christina Gibbs took that over and is leading it just in a fabulous way. We're trying to expand our partnerships. But basically in talks, what I usually say is that we're doing things, we at NASA, but the whole world are doing things in a very, very different way than when we first went to the moon back in the 60s. Back then, it was a space race between the United States and the Soviet Union. Thank goodness it's different now. And what we want to do at NASA in general, but particularly SURVEY, is raise the tide for the whole world and engage the entire world in this wonderful effort that we're doing to return humans to the moon and to harvest these fabulous scientific results. So anyway, it's like I say, it's an honor to support this effort, and you can count on our support for a whole lot of years to come. Great to see all of you. Thank you.
Thank you very much, Greg. I think we are almost back to time. We should be back to time. So the only thing remaining is a bit more interaction with the audience here. So if I could invite all those who spoke in the previous session, somehow take care while walking up the steps onto the dais here. And then we will invite questions from the audience. And we have Anil online. He also has a very exciting announcement to make or share with you. So I will invite him at an appropriate time. Do we have Sarah? Yeah, Sarah. And who else are we missing? Yeah, please. So think about a question and be ready. And you raise your arm and I'll try to. Yes, Dan? Could you join us? Yeah, so everybody who spoke in the previous session. Ricky, do you need to do something? Oh, run the microphone. Maybe best will be if I repeat the question, so that saves time. This one. Okay. Yeah, and I'll pass the microwave, so that way we'll save time. Okay, all right. Well, this is such a distinguished company, and I think I said right at the start of the meeting that this was an experiment, and I hope that you will forgive us. You know, we are not a professional organization organizing this meeting, so all we are driven by is our enthusiasm for bringing the community together, for discussing the best science and exploration that is out there about the moon to begin with, but then going beyond the moon, and therefore I first of all, I would like to apologize to all these speakers because they never had enough time to share their vision and program with us. But hopefully they will all return to a bigger and better format next year and the year after that to the future editions of European Lunar Symposium. So thank you for being with us today and for persevering. First question from the audience. I can see Bernard. Bernard, you have a question.
Community, great job on this panelist, mostly presenting government program. So now my question is, how do you work with new space economy, with the industry, able to get some money to pay research?
Okay, so Bernard's question is that so far we have heard mainly the government supported or backed lunar exploration, although I think there were a few that were not necessarily. Yeah, so who would like to respond to Bernard? Is that how is that private and public partnership going to work in future? Did I capture that question right? For research, money for research.
What we've
Dan.
done, yeah. I'll start off by what we've done. It's not fair because we're experienced with it. The agency itself provides support, provides very limited initial funding. All of the funding for the big funding comes from private, either philanthropy or industry. Industry is heavily involved. We also support funding for startups as part of the regular support for startups in Israel. And it works well for us. One of the big issues that we have to be involved is in the international collaboration. That does require G2G agreements, government to government, and that's where the agency comes in as a government agency. As I said before, we're actually all employees of universities or other organizations. That's how it works for us. I don't think that that's the case for most of the countries.
Thank you very much, Dan. I think, Greg, you have something to add?
Yeah. My institute has been involved with lunar commerce since the very beginning. The Google Lunar X Prize was announced, I think, 2 months before the formation of the NASA Lunar Science Institute, and so we have been working really closely with all those companies. Some have come and gone, and some have survived, but we've had a couple of workshops focusing on this in particular, most notably Lunar Science for Landed Missions, which was around the time of the inception of the CLIPS program. In addition to that, our survey research teams in the United States, as well as our international partners, have the commercial entities at their core. A number of them, for instance, the team led at University of Central Florida by Dan Britt, partners with quite a few commercial companies on a wide range of projects. So, James, did you? Sure. Yeah.
So we have I think a drive from our leadership to look into how we can commercialize things when it's possible to do so. So we have at the moment a commercial partnership for the moon on Lunar Pathfinder, which will be an ESA communications relay satellite created in partnership with Satellite Technologies Limited, which will be delivered to the moon through Eclipse delivery, which is again a commercial action from NASA in partnership with them. We're looking into future communications relay networks in a commercial partnership too. So these are two sort of very concrete examples now, looking at where we see there's a real market that's going to be available that the commercial sector in Europe is interested in, which is in communications. We are working with Astrobotic for the delivery of LAN-CAM-X, which is a technology payload which we delivered to the moon surface with Astrobotic as a commercial procurement. And so we're looking at where does it make sense to do things commercially versus in a more conventional institutional way. And when there's partnerships, it's generally around areas where the commercial sector has an interest. In general, the commercial sector is not that interested in fundamental science on the moon. So we don't see a huge amount of opportunity or interest there today. Where we do see some connection is in things like resource prospecting, understand the resource of the moon. Now, there is no market today really for resources on the moon, but there might be one day. And so that's where we're in this kind of gray area at the moment about, is this commercial, is it not? What is the interest of the private sector in that? And that's something which we're also exploring. Anyone else?
So in Japan, traditionally, space agency, JAXA used to order to the commercial industry. But nowadays, we're changing our mind. We recognize that especially the newly emerging industries interested in becoming a player rather than just a provider of the parts or the items. So now we're shifting the way we work with industry. We try to involve them already from the planning phase, listen to what they want to do. So yeah, that's a change. It used to be a one-way thing, like order and purchase, but now we're trying to communicate from the beginning.
Thank you very much. You can keep the mic that way because we have got can use
this one. So I think that this is this question. Each one of the countries' government has probably a different answer. For what concern Italy, I would like to underline that the commercial partner has a sense for some part of the exploration, for example, the services, transportation, communication, or other things like that. For what concerns the basic research, our opinion is that this must remain in the government-funded activity, because this is the only way to guarantee, let's say, a very equal opportunity for everybody in each science topic and so on. This is in very short.
Yeah, thank you very much. I think you go ahead.
Yeah, in the case of Korea, we are now trying to do more missions, lunar mission and orbiter and lander, and then we're gonna go for Mars for orbiter and lander as well, all planned. But right now, at the moment, Hyundai and then Korong and also Boryong for with the Axiom and Kolon. So there are many large companies, right? Hyundai is very large. So very large, within 1/10 of the ranking, the company actually, they are emerging to space industry, not only small countries, small the industry as well. So I think with your question, you know, in the case of Korea, it's really space economy is booming, and then the Europe or some other nations also. I mean, the industry, the companies are also contacting us to collaborate. So I think sooner or later, I think this will be a very interesting way that we can collaborate together with in the bigger Korean industry, as well as the starting of companies together with the European or other, you know, the international partners. So that is happening. Thanks.
Okay, thank you very much. Anil, did you want to add something, or shall we take another question?
Thank you, Mahesh. Yes, in India too, we have governmental support for private players to come into space exploration. It has been a support from the government to start a new entity, which we call as InSpace in India. And that consists of commercial as well as several startup companies. So I hope that will be sufficient for.
Okay, thank you very much. So while we take another question, I would like the panelists to keep in mind another part of the question, which was the support for basic research, which I think our colleague from ASI, addressed this partly because we have the next generation here in this room. And many of those in the next generation are doing fundamental research, either through their PhD or postdoctoral research, or even as a research scientist. So I think what we need to tell them is how their work actually connects with what the government or the commercial agencies are looking for. So, it could be that much of the work they are doing is going to underpin, but it still has to be translated to be of commercial or economic value. So if anybody wanted to address that, maybe now or later, please do so, because that's really important.
I can maybe say something just from ESA, and just in terms of more kind of structure and how it works. Just for those who don't know, ESA will generally not pay. It's not our mandate to pay for people to do science, right? So we are generally would build infrastructure, we build capability, we would organize missions. Sometimes we'll do payloads on international partner missions, but the scientific use of the data that's generated by those is not something that normally ESA can support. So for that, you would need to work with your national agencies, national funding bodies, to get the support to do the science with that data. And that's an important part of the way that ESA partners with and the way that the relationship works between ESA and its member states.
From your position, you say reduction we like also that to explore how you use all these transformation funds from Europe.
I do think the point is just to be in Europe, we have a very complicated mix of different funding sources, and we just need to make the best of all of them.
Great, thank you. Let's move on to the next question. Tom, did you have a question or a comment?
I'm going to ask, but James, I think addressed it. As I have
Right. So I think this is a topic that we could spend a lot of time discussing, and there isn't going to be one answer for any given agency. But I just wanted to make sure that we do not leave behind the real workforce that is going to underpin everything that is going to follow. The situation is very complicated, how space agencies actually work to deliver onto a mission. But the main message is that they cannot deliver without the workforce that is required to do so. So what we are seeing here is an evolution of that process in the last 10 years. Certainly I have seen since I have been involved with. There were fewer lunar missions 10 years ago. There are many more. The rationale for those lunar missions have also changed. What we are looking to get back from them and the opportunities, I think, have multiplied massively. So I would just like to send a message to all of you who are here and then who would interact with your peers elsewhere, is that there is going to be tremendous opportunity in this area for everybody. We just need to find a way to make that opportunity come to fruition. So more questions, please, from the audience. Oh, there is one here. I can pass on the mic to you.
Thank you so much. This was very informative to me. I'm new to the lunar ecosystem. I'm representing Astrolab here. And I had a question for you, Sarah, for the UAE rover. You said that you're going to be partnering with a commercial lander to fly that 25 to 30 kilogram rover. So I was wondering if you'd made that selection and how that process works. And just curious, just following up on the previous question about how can commercial, new space companies partner with governments. I was curious about that selection process. Thanks.
In MBRC, we believe in the importance of the partnership with other entities, and especially the commercial entities. And that's why the first mission went with iSpace. And it will be the same. We found it's valuable. We have a very excellent experience with them. And we are working towards having the second lander this month. So it's under investigation, seeing the schedule, seeing the mass available, and the location, of course. Yes. So yes, the commercial as one of the target. No.
Any other question? Roma? Okay, so the question from the audience is that there was a mention of a sample return in JAXA presentation, so we want to know the timeline.
Yes, we have been performing some astral sample return mission, and when it comes to the lunar sample return mission, it's kind of easy because we're bringing back astronauts back to Earth, and samples are tiny, add on to that system. So in that sample return concept, we are thinking more about how do we pick up the right samples. And compared to asteroid, we know much more about the moon, and we know that the lunar surface is diverse. So we know that what sample we will get if we get to this spot. And that spot might not be accessible by human astronaut. So we should send a small rover to there, and somehow maybe we drill into the rock and get the sample, the core sample. And then how do we fetch that sample? Maybe the astronaut, big rover on which astronaut is riding may not be able to access to that point. So then we have to transfer that sample to a more safe area where finally astronaut will grab and then bring back to Earth. So it's that kind of scenario that we are developing now. So it's the synergy between small robotic mission and a big human mission.
Okay, any other question? There's one here. I can lock the mic to you, but I can repeat probably. Yeah.
They haven't been selected already. There'll be a distant one from the other.
Okay, so let me just repeat the question because people online would not have heard you. So I think the question is about the choice of landing site selection for Parachute 2 mission.
So I'll say there is a scientific committee for the Parachute 2. Most of the people are lunar scientists on on that committee. It will be selected by them. There'll be, as usual, the engineering concerns and the scientific concerns. Scientific of gaining most data as possible, and engineering making it cheaper and simpler as possible. And between the two, you have to balance the that equation somehow. Yeah, but that will be decided. It hasn't been decided yet.
You have time for maybe one quick question. There's one. Emily, yeah, far away. No, I will repeat if you just ask the question. Okay, so the question was, and I think this is very close to me personally, it's about how do we actually engage and inspire the next generation using a coordinated effort throughout the world, using at least the group of agencies that are present here. So would anybody like to start answering that question? Okay, Dan.
I want to start off by saying that the reason that I'm here, other than you asking me to come, is the issue of collaboration. I think that the days of one nation working on itself for geopolitical reasons are gone, and most of what we're doing is for science and exploration, and that we can do only through collaboration. Most countries don't have the funds or the capability of doing it alone, and there's no reason to do it alone. I have a lot to say about how that brings peace, but
One of the vehicle of this to answer to this question is, for example, the Global Forum of International Exploration Coordination Group, which collect most of the countries and get together to plan with the roadmap for exploration. And this is a mean to divulgate, to disseminate what the world, the main agency at least, are doing in the field of exploration, human and robotics. So, but there are also other forum, other groups, organisms like that, in which, of course, we have to improve because the scenario is changing. But these are the best way, in my opinion, to disseminate and to let know the people what the countries are doing in the exploration.
So, Emily, I think that's a fabulous question. I want to say in terms of SURVEY, this is one of our 5 core missions, inspire and educate. So it has been that way since the beginning. That being said, the specific question was, is there work between all of us to do that? And to my knowledge, there is not. Artemis has really just started up its efforts to do this. We're working some with the Artemis team on that, but I think it's an excellent idea. And so since there are a lot of SURVEY partners here, I'd like to raise this as a challenge for us to work together, because really what we're doing, I guess I can reflect myself. I was 10 years old when Neil and Buzz landed on the moon. I remember it really well, and I was inspired. I wanted to work with NASA, for NASA, even before that. And so what we want to do is do the same thing for young people right now. There's an incredible journey that humankind is about to take together. And what an opportunity to use this to inspire kids this time all around the world. And so I think that I take it as a challenge for us at SURVEY Central, for our teams and for our partners to all work together on this.
to echo a little bit what Greg said, I think that there are some there are some messages around about why we're doing this. And there's two parts. There's the inspirational big message, why are we doing this stuff? And there's education, which is something a little different, which also came up in the question. So I think that there is, as you say, I don't think there is a concerted effort today to have a unified single, all the agencies saying the same thing, why we're doing this. I think that's a really interesting idea. I think there are some common lines on why we do this, and there are some divergent ones. And some of those are quite controversial, and some of those are very simple. I think it's perhaps this attention on the why, and do we agree on that, is a really interesting idea. One thing that well, my leadership has reminded me on several occasions is that in ESA, we have a strategy which was the basis for our strategy goes back some years and identifies the four cornerstones of why we do this, which are inspiration, technology, science, and international cooperation. And those go back to something which predates that, which was the Global Exploration Strategy, which is the thing that started the International Space Exploration Coordination Group as it is. So those things all kind of stem from this one place. So there has in the past been some convergence of ideas, and I think we can build on that again. In education, those specific kind of education-like programs, they tend to come out of particular projects and programs. Within the Gateway, we're putting that together now as an international project, and within that, we are looking at how we can collaborate on education in the context of Gateway. As lunar exploration within human missions, for example, becomes more of an international cooperation, which at the moment it's not, but it's becoming that. I think we'll start to see that emerge in there too.
I think the coffee is getting a bit cold, but before you go, I would just like to invite Anil, because earlier this February, I was visiting India and he very kindly hosted me as his institute, and I learned a great deal about the level of public engagement and outreach effort that's taking place there. But also, Anil, you have to make a special announcement for the community. So could I hand it over to you for the next minute or so, and you can share your thoughts.
Okay, thank you, Mahesh. I'm really missing all of you standing there. So, you know, the agency partners, and I would have loved to be there and talking, and particularly over the coffee. Since I could not come over there, I thought I will call you to India, and where we are planning to have an international conference, which will be in the end of January next year, that is 2024. And the ideas was floating to have first a lunar conference, then we said it should be planetary conference, then exoplanets got joined, and then habitability also is getting joined. And so the plan is to have an international planetary or planets, exoplanets, and habitability conference. And it is going to be in Ahmedabad in India during the period of January 29, that is 29, to February 5th. So it will be about a week-long conference where people from different areas of planetary science, exoplanetary science, and habitability would be coming together. And the reason for hosting this is that India has been doing planetary exploration for last 2 decades. And we wanted to call all the world to come to India to look at what we have been doing for the last 2 decades, and also to build international cooperation, because that is what is very, very important. And to do any planetary mission, we do need to come together. And that's why we invite, or I invite all of you to come to Ahmedabad next year. Thank you.
Thank you very much, Anil, and thank you, everyone.
Thank you.
So let's close this session. Let's go and get coffee. We are behind by half an hour, so we start 11:30 sharp. So we have got 25 minutes to have a chat over coffee. Thank you.
Qualche sessione c'è, se quella